Bismillahirrahmanirrahim. Topic 5, relationships in triangles. Lesson 1, perpendicular and angle bisectors. This is our main objective, to use the perpendicular and angle bisectors to solve problems. Let's see what are perpendicular and angle bisectors. First of all, perpendicular bisector divides a line segment into two equal halves. Whenever we draw a perpendicular bisector, for example, here I have a line DE, and when I will draw the perpendicular bisector, the DE will be cut into two equal halves. So this part will be equal to this one, and here we can show that this is making a right angle with the line DE. This perpendicular bisector, the red line, it will make the right angle with the line DE. And when we talk about the angle bisector, then it divides the angle bisector, this line, the angle bisector, it divides the angle into two congruent angles. So we can say that this angle will be congruent to this one. So let's see what do we have next, like what is our first theorem to discuss. So here is theorem number 5.1. It says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. What does it mean? It means that, for example, if you have a line PQ and there is a point on the perpendicular bisector, for example, here I have a point R, then this point R, its distance from the endpoint P and its distance from the endpoint Q will be the same. Like, for example, if this distance is 5 centimeters, then this distance will also be 5 centimeters. So if you have a point P on the perpendicular bisector, then its distance from X and Y will be the same. So we can say PX will be equal to PY. Next, we have the converse of this theorem. It means that if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector. Same thing, like if you know that this point is equidistant from this point and this point, the endpoints of the line segment, like point R has the same distance from point P and from point Q, then it will be lying on the perpendicular bisector. So what do we know? We know that this distance PX is equal to PY. We know it. Then what will happen? This point will be on the perpendicular bisector. If this point is on the perpendicular bisector, then we can say that this XQ will be equal to YQ. These two distances will also become equal, and PQ will be perpendicular to XY. Like this line PQ will be perpendicular to XY. Let's solve an example. It says what is the length of QR. So first of all, we have to decide that what is this diagram for, what is it about. So clearly we can see here that there is a right angle over here and we have two equal segments. This means that there was a line segment PR and this is showing the perpendicular bisector. Why QS is the perpendicular bisector? Because it is making a right angle with PR and also it is cutting it into two equal halves. So this is all about the perpendicular bisector, this diagram. So I can say 3n minus 1 will be equal to 5n minus 7 because this point Q will be equidistant from R and P. So I can say that PQ is congruent to or equal to RQ. Why I'm making this equation? So that I can find the value of n. Until I will not find the value of n, I won't be able to find the value of QR, because I have to substitute this value of n here to know how long is this QR. This is what they want us to find. So how can you solve? Let's move this 3n over here and this 1 over here. This is 7, sorry, this 7 over there. So it will become 5n minus 3n equals negative 1 and plus 7. So this one will give us 6 and this one will give us 2n. Now divide each side by 2. It will give us the value of n equals 3. Is this our final answer? No, because we found this value of n only to find the length of QR. So what will be the length of QR? It will be equal to 5n minus 7, and now you can substitute the value of n to know how long is this QR. So this one will be 15 minus 7, so it will become 8. Clear? This is a triad question that I took page 204. It says what is the value of Wi? Now first look at the diagram carefully, that are they talking about the perpendicular bisectors? Yes, they are talking about the perpendicular bisector. How we will know that? Because we have a right angle over here and this point Z is equidistant from the endpoints of the line segment XY. So we can, in step 1, why we have to do step 1 and step 2? Because first we have to find the value of the variable n. So it will be 5n minus 2 equals 2n plus 7. So move this 2n over here and move this 2 over there, so that we can have the variable terms on one side and we can have the constant numbers on the other side. So it will become 7 plus 2 will be 9, and here we will have 3n. Divide this side by 3, this side by 3, it will give us the value of n, that is 3. Okay, this one was all step 1. What we will do in step 2? In step 2 we will replace this n here in Wi. So how long is Wi? Wi is actually 2n plus 7. So replace n by 3. So it will give us the value equals 3 to the 6 plus 7. It will be 13. Right? Now in 4b it says how long is OL. So we can see over here that this is OL. Now actually there was a line segment that was JL. JL is 14 on this side, and this JL is actually JL is the main line segment, and this KN is the bisector of JL. How I know that this is a perpendicular bisector? Because of this right angle, and because they are point J and L, this point K is equidistant from J and L. So this one is equal to this one. This shows that JL, this longest line was cut into 2 halves. So if you have 14 over here, how long will be NL? So NL will also become 14. Now after, if you understand this part, now go to the second part. Now look at this one. This one is also the perpendicular bisector. Same case, because we have a right angle, and this point M is equidistant from the from point NLL. That means that this is the perpendicular bisector. So if this whole line NL is 14, so how much will be OL? It will be half of the NL, right? So what is half of NL? It will be 14 divided by 2, that will be 7. So you can say that OL is equal to 7. Clear? Now let's discuss the theorems about the angle bisectors. So the first theorem 5.3, it says if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So this is an angle, right? Angle A. Now if we have a point, this is the angle bisector. How I will know that this is the angle bisector? Because they put these symbols over here to show that this angle is divided into 2 equal parts, or divided into 2 halves. It has been bisected, right? Now if you have any point on this angle bisector, then the distance of this point from the, you can say from the sides of the angle, or you can say from the legs of the angle, it will be the same. So this distance BD will become equal to CD. It means I already know that this is the angle bisector. This ray is showing the angle bisector. I will take any point on this angle bisector, then the distance of this point from the legs of the angle, or you can say from the sides of the angle, will be the same, and this angle will also be a right angle. Clear? Okay. The converse of this theorem is like if a point is in the interior of an angle, it means that I know that this is an angle. For example, this is an angle A. I have a point in the interior of this angle, and this point is equidistant. If this point has the same distance to this leg and it has the same distance to this leg, then we can say yes, this then it is on the angle bisector. That means this point will be actually on the angle bisector of that line. And we can make the result that angle BAD will become congruent to angle DAC. What is the difference between the two? Because here they already showed that the angles are, this half is equal to this half, these two angles are congruent to each other. But here you can see that they didn't put this symbol. That means I know that this point is in the interior of the angle, and it has equal distance from the end point, from the sides. So I know that BD is congruent to CD, right? Then I can say that this point is lying on the angle bisector, so angle BAD will become congruent to angle CAD. Clear? Let's solve try it number 6. It says use the figure shown. So you have to look at this diagram carefully, that what is this about? Is this about the perpendicular bisector? Is this about the angle bisector? When you will get the idea, then it will become very easy for you to solve the questions. It says if HI is 7 and IJ is 7, so this HI, this is 7, and this IJ is also 7, and the measurement of angle HGI, this angle is 25 degrees. Now what is the measurement of angle IGJ? They want us to find how much is this angle. Now first I will decide that is this a diagram about the angle bisector? Yes, this diagram is about the angle bisector, because this point is equidistant from the legs of the angle or from the sides of the angle. So that means it is lying on the angle bisector. If it is lying on the angle bisector, that means that angle HGI and the angle IGJ, they will be equal to each other. So what is the value of angle HGI? It's 25. That's why we can say that angle IGJ will also be 25 degrees. So the measurement of this angle will become 25 degrees. Clear? Now look at the second question. It says, the B part, it says if measurement angle HGJ is 57, so let's erase it and see how can we use the diagram for the second part. HGJ, the whole angle, they are talking about the whole angle, it's 57 degrees. And IGJ, this one is 28.5 degrees. The whole angle, if you talk about this whole angle, it is 57 degrees, right? And HI is 12.2. This one is 12.2. What is the value of IJ? So they want us to find that how much is this line segment IJ. Now, if you notice that right now, this is, you can say, the converse of the first part. How? Because I know that 57 is the whole angle. What is the half of 57? The half of 57 is 28.5. Right? If you divide 57 by 2, it will give you 28.5. This means that if they are talking about the angle bisector, so if this angle is 28.5, so this angle for sure it will be 28.5. So if this point is lying on the angle bisector, then it will be equidistant from both the sides. So we can say that IJ will have the same measurement like HI. So it will become equal to HI, and that will be 12.2 units. Clear? Now let's solve some questions from the lesson. It says, it's question number 14. It says if AD is 3, AC is 8 and BD is 3, what is the perimeter of this triangle? So let's first write the measurements over here. They said AD is 3, so we can write 3 over here. AC is 8 and BD is 3. Now, is this diagram about the perpendicular bisector? Yes, because look at this. This line has, this line DC is making a right angle with AB, and it is cut into 2 equal halves. So this means that for sure this distance will also become equal to 8, because this point will be equidistant from A and B. So our diagram is ready. How do we find the perimeter? For the perimeter, we add all the, you can say, all the sides of the triangle. So how long is this side AB? This is 6. So we can say 6 plus how long is BC? It's 8. And how long is CA? It's 8. So the final answer will become 22. So the perimeter of this for this triangle will be, you can write perimeter for triangle ABC is 22. Clear? 22 units. Now I want you to solve this question on your own. This is question number 16. First, look at the statement that is given with the diagram. Try to put these values into the diagram and then solve it on your own. Play the video to check your answers when you have solved it. Very simple question. The only thing that you have to decide is is this are they talking about the perpendicular bisector? Yes, they are talking about the perpendicular bisector, because here they gave us this measurement is 8, this measurement is 8, and there's a right angle over here. So AD will have the same measurement like AB. So both of them will be 21 and 21. Here is the next question that I want you to solve on your again. Pause the video here. First get the answer and then play the video to check your answer. Here is the answer. Very simple question, because we can see from here that this measurement is 5 and this measurement is 5, and the point W is in the interior of the angle YXZ. This shows that this is actually lying on the perpendicular bisector of the angle YXZ. They want us to find this angle ZXY or YXZ. It's the same thing, ZXY. They want us to find this angle, and one of the angle is given 21. So because it's lying on the angle bisector, so this angle will also become 21. So you can say 21 times 2 or 21 plus 21. The final answer, the whole angle ZXY will become 42 degrees. Clear? Next question, question number 20. It says if CD is 4, so where is CD? CD is 4, this one is 4. The perimeter of the triangle ABC is 23. So they have given us the perimeter for this triangle, and it says that it's 23. So we can say that if I add all these sides, this one, this red side, and this red side, and this red side, it will become 23. But they want us now to find the perimeter of the triangle ABE. So they want us to find the perimeter of this whole triangle ABE. Perimeter of triangle ABE. This is what they want us to find. Now actually they didn't give us any measurements, but I can write over here, because this is the perpendicular bisector, so I can write over here 4. That means CD and DE, they will have the same measurement. Now if I push this red line from here to here, it will not make any difference in the measurement. Why? Because they are equal to each other. So this shows that if I add this blue line and this red line and this red line, it will be 23. I want to find the area of the whole triangle. So from here, if I start from here, this blue line has the same length like this red one, and you go here and you come back to this point. So this all, it gives me 23. Plus, if I will take this 4 and I take this 4, it will give me the perimeter of the whole triangle ABE. So we can say that to find the perimeter of triangle ABE, I have to add these measurements. So it will become 31 units. Clear? Here is question number 26. It says point G, J, K are not collinear, and GJ is equal to GK. Okay, this shows that if you go from point G, G is the common point. So if you go from point G to J, let's say you go like this to point J, and if you go to point K, these distances are equal to each other. Next they are saying they are not collinear. Not collinear means these 3 points will not lie on the same line. Okay, next they are saying if P is a point on JK. Now let's draw it with the blue color. They are saying that there's a point P here. We don't know where is it, but let's say it's here. So if this point P is lying on JK, they are saying which of the following condition is sufficient to prove that GP, like this GP, is the perpendicular bisector of JK. Now because these two are equal, that means that the line that will be joining GP, it should make a right angle with the, according to the theorem, it should make a right angle with this point P. Now which one is showing? Now let's discuss them one by one. JG is equal to PG. Where is PG? This one, PG. We don't know this information. We don't have this information. Okay, then they are saying angle GJK angle GJK is equal to angle GKJ. Even we don't have this information because they didn't mention it. I mean, even if I will have these two angles equal, I cannot say that this one is lying on the perpendicular bisector. This point P is lying on the perpendicular bisector. Next, they are saying angle GPJ, this one is 90 degrees. Yes, this one will help us to decide, because P is a point that is, you can say, it's lying on the, it's making the right angle with the GP is making a right angle with the line JK. So this is the correct option, right? And next they say PK equals PG PK. Where is PK? This one is equal to PG. No, we don't have this information. This one is also wrong. So this is the correct option that will help us to say that yes, this point GP is the perpendicular bisector of GK. Clear? Here is the homework question. Better pause the video here, solve it on your own, because we have discussed many cases, we have solved many questions together, so I am sure you can solve it on your own. Then play the video to check your answer. Here is the answer. BD equals 3.5 because this one will be half of it, because we can see it's a case of perpendicular bisector. So this one will be equal to this one. So you will divide 7 by 2 to know how long is BD. Next, there's another homework question. Pause the video, solve it on your own, then play the video to check your answer. Very simple question. They want us to find how long is this line segment BD, and they gave us the value of DC, that is 3.3. So because this measurement will be equal to this measurement, so you will multiply 3.3 by 2 and it will give you the answer. Next, we have another homework question. Again, solve it on your own. Play the video then to check your answer. Here is the answer. WY will be, or YW will be same like 8.1, because this is the case of the angle bisector. So the measurement that is here, if you go from the you can say from the angle bisector, any point from the on the angle bisector, you go to one of the side or you go to the other side, it will be the same measurement. How do we know that this is the case of the angle bisector? Because this whole angle given is 38, half of it is 19, so for sure the other one will be also be 19, because 19 and 19 together it gives us 38. So we can see that this is the case of angle bisector. Here we have some challenge questions. Again, I want you to pause the video here, solve these challenge questions on your own, and then play the video to check your answer. Here is the answer for the challenge question. The first one, it was saying like what is the perimeter of this triangle. So it's very simple. You will put the values into it. This value will also become 12, and when you add all of them it becomes 34. So this is the correct option. Now the second question, it's a little bit tricky because you have to choose all the options that are correct. So as you know that whenever a variable is involved, we have to, in step 1, we have to find the value of that variable, and even here in A part they were asking us to find the value of the variable. So this part will become equal to this one, because this is the case of the angle bisector, perpendicular bisector. So when you get the value of n, it becomes 4, and here the first option says n is 7, so that's why the first option is wrong. And I have solved here it with blue color, and here I put the cross with the blue color. Now the second option was like find the measurement of QS. So when you look at the diagram, QS says it's 6n plus 3. So you will replace n by the value that you got here. It's 4 and it is giving you 27. So this red part is B for B, the red ink is for B, and it's wrong. Now the third part, I solved it with the green. It was saying find SR. So SR is actually 3n plus 11. So you will substitute the value of n. It is giving you 27. So yes, this option is correct. This one is correct. Then in the last option they were saying find QR. QR means from here to here, how long is this whole line. So we got here in B part that this is becoming 27, this one is becoming 27. So if you add 27 and 27, it gives you 54. So that's why the last option is also correct. Hope it's clear for you. Now the last question, the last challenge question, better pause the video here, put the values into the diagram. This will be your first step always, that whenever the values are given in the form of the statement, you have to put these values into the diagram. Then the picture will become very clear for you that what you have to actually do. Okay, better pause the video, complete it, and then play the video to check your answer. So very simple question. After substituting the values, we know that they are discussing, actually this case is for the angle bisector, so that's why the point y will be equidistant from both the sides. So xy will be the same as yz, it will be 16. That's all for this video, all for this lesson. Hope you understand it.